This is section 1.1 of Math 110. We're going to start off looking at functions and function notation. We're going to talk a bit about relationships and then specifically what determines whether a relationship is a function. We're going to do a lot of time, and this will persist through the course, evaluating functions and solving equations, okay? And we're going to look at functions in context, meaning the contextual information about a function. So the words or the situation that's associated with the function. We're going to also cover business functions. That's going to be very important in this class and then in future classes if you continue on in the sequence. And then we're also going to look a lot at what we call toolkit functions or library of functions, or you may have heard of them called parent functions previously. Those you'll be expected to recognize all the different aspects of the toolkit functions as we progress through the course. So a relation or a relationship is a set of ordered pairs. And there's two pieces that's sort of implied when we talk about pairs. So we've got inputs and we have outputs. And the inputs, another way to refer to them, or another definition of the inputs, we call the domain. So each one of these first entries here, the inputs are part of the domain of this function. And then the second component we can think of as the output or the range. And so we have inputs and outputs, okay? So for each set of ordered pairs here, when I input 1, in this case, I get an output of 2. Here, when I input 2, I get an output of 4, and so forth. So we can further write, we can write in ordered pairs the relationship. Or we can write the domain, which we'll do frequently, and just indicate all the elements of the domain. So in this case, of these relations here, I've got 1, 2, 3, 4, 5 as my domain, and I include them here with these little brackets. So all of these elements or components are the domain. And then I can summarize the range together by pulling each of the outputs, 2, 4, 6, 8, 10. And so the range is comprised of 2, 4, 6, 8, 10, all of the outputs of this relationship. We can also represent inputs and outputs or functions using a table of values. And we'll do this quite a bit in this course as well. So I can create a table. Here I input, here's my X values, and then I output my Y values. And we're always going to have, when we write it in table form, the inputs are always going to be on the left side, and the outputs are always going to be to the right of that. And so I can read this table here saying I input 1, right? And then I get an output of 2. And so each set of ordered pairs I can represent in the table here, right? I've got 2, 4, 2, 4, 3, 6, and so forth. We can also describe the inputs and the outputs with additional descriptors. So our inputs are also called our independent variable, and our outputs can also be referred to as our dependent variable. And all that really means is that the output value I get depends on what I input to my function. Lastly, we can represent relationships and functions graphically, and that's what I have here. So if you notice this point here, okay, if I read, if this is my x-axis and this is my y-axis, and we're always going to have the inputs on the horizontal axis, and we're always going to have our outputs on the vertical axis. So these are my outputs here. And so in this case, if I read over, I travel over to 1, that's my input, and then I travel up to this point here, and I get the coordinates, or the ordered pair says when I input 1, I have an output of 2. So again, I can plot each one of these, right? Each one of these points here. If I look at this point, I come over, I'm going to input 5. I travel over to the output and I output 10. So I can represent or write this as 5, 10. When I input 5, my output is 10. So the question is, how do we know if this relationship is a function? A function is a special type of relationship and has a very specific meaning. So when we define a function, it's a specific relation where each input value, each specific input value has exactly one output value. So you want to think about it as scanning your inputs, and for each input, they cannot have more than one different output value. Now, that's not to say that's not an important relationship. It just doesn't meet our definition of a function. So we say the output, if we want to write this in words, we say the output is a function of the input. And again, my input values make up my domain, and my output values make up my range. So if I look just as a picture here, I can see in this case, this one's saying that this relationship is a function. I like to sometimes write these as ordered pairs. So this says that if I input P, I travel over here, I get an output of M. This says if I input Q, I get an output of N. This last one says if I input R, I get an output of N. So even though both Q and R result in an output of N, this is still a function. My definition of a function says that each input has only one output. So I don't have multiple outputs for Q. I don't have Q equals N, or I don't have Q equals N and Q equals M. Each one of my inputs has exactly one output. Here's another example of a function. And again, sometimes I like to write them as ordered pairs. I input P, I output X. This one says I input Q, I output Y. This one here is I input R, and I output Z. So each input has only one output. And then here's an example of a relationship that is not a function. So in this first case, when I input P, I output X. Here, when I input Q, I output Y, but that's this thread here. But also if I input Q, I output Z. So now I have a single input Q. Sometimes I get a Y, sometimes I get a Z. So that tells me this is not a function. All right, let's talk about function notation and sort of how to translate into words function notation. So when I write something in function notation, that's this sort of definition here. I have y equals f of x. And this tells me that I have some function named f, okay? And I read this as y is a function, or equals is a function of x. So again, if we go back to our inputs and outputs, the letter X represents my input. The input is always going to be inside the parentheses, okay? So you can remember that the input is the thing inside the parentheses. And that, again, we can also call the independent variable. So that's input is inside the parentheses. It's my independent variable. The letter Y is my output, or my dependent variable. So let's look here. I've got them written out. I can write them a couple different ways. So I say y equals f of x. And I've color coded here so you can kind of see if I translate that, y is equal to, that is sort of maps to the equal sign. We've got f represents my function, and a lot of times these parentheses will translate to the word of x. And so again, I can talk about this as inputs and outputs. The output is equal to f of the input. Over here, I can write it, sort of reverse the order. I can say f of x equals y. And so when I sort of say this, I say f of, that's my parentheses, x equals y. Okay? And I can also say f of my input is equal to my output. Okay, so these are all different ways that you can say in words or translate the function notation. So you should get familiar with seeing it different ways and being able to understand when you read a word problem what the input is versus what the output is, and some of these key words that will help you determine that. All right, so we're going to go through most of this course where we're going to look at things in terms of algebraically or using equations or formulas, graphically, or with tables. So we can represent functions using tables here. And so if we want to determine if this table of values is a function, we need to determine based on the definition, does each input have exactly one output? Now, what I want to tell you is that if you have a table here, the input is always in the top row and the output is always in the bottom row. Okay, that's just conventionally how we set these up. Input, output. All right. So again, if it helps you to write them in ordered pairs, go ahead and do that. So if I look at this first here, right, I can say f of x equals y. So I can translate all these into ordered pairs, or I could say, I could write them in function notation, f of 2 is equal to 4, or that is 2, 4. I can write it as an ordered pair. That's all different ways to write this column of my input-output table. So I've got input 2, output 4. Then I've got input 4, output 7 right here. And then I have input 6, output 4. Okay, so each input has, I don't have any inputs repeated here. So this is a function. Now when I look here, when you look at a table, sort of the key is I can see already here there's 2 inputs of 4. Okay, so let me write these as ordered pairs, 2, 7, input 4, output 5, and then I can when I input 4, I output 4. So here I have an input of 4, but sometimes I get an output of 5, and sometimes I'm going to get an output of 4. So this is not a function. All right, and when I look here, all of these are different inputs, and so we're good here. So this is a function. All right, so down at the bottom here, if you want to print these notes off, you can. So we want to identify inputs and outputs. We want to make sure that each input is paired with exactly one output to see if it is a function. All right, so there is kind of a shortcut, which some of you might be familiar with. And if we have a graphical representation of a relationship, that we can tell if it's a function by using what we call the VLT, or the vertical line test. Okay, that's what VLT stands for, vertical line test. And really what that means is, and you can, grab your pencil or, and vertically travel along your relationship. And you just want to see that no matter where I travel along this curve, when I have a vertical line, it just will go through that graph at one point and only one point. Okay, so if we take a look at this next one here, if I'm at this, right at this end here, and I get what I call it, this little tangent, it just goes through one point. But as like everywhere else on this graph, if I drag a vertical line, I'm actually going to have, it's going to go through 2 points. So let's say this input here is 1. and that's 2 and negative 2. So here I would have, when I input 1, I could get a negative 2, or sometimes I could get a positive 2. So this is not a function. Okay, similarly over here, okay, if I drag this vertical line, okay, across this function, I can see that there are many x values or inputs that will give me more than one output, or specifically, I'll get 2 outputs. Okay, so that is the vertical line test when we have a graphical representation of a relationship. All right, so let's talk about evaluating and solving functions. Those terms or definitions those terms have very specific definition and meaning in math. So they're not interchangeable. So when we say that we want to evaluate a function, it means we want to find the value of the output when we're given a specific input. That is what evaluate means. Again, find the value of the output when we're given a specific input. The input is inside the parentheses. So I've got my function defined here with a formula, y equals 3x plus 1. Now I could also write that as f of x equals 3x plus 1. Sometimes it's more beneficial if we write a function using y, but sometimes it's better, or not better, but sometimes it's more helpful to write it in function notation. So we know that y is equal to f of x, so we can either say y equals this thing, or we can say f of x equals that thing. So in this case, I'm given an input of 2, and I want to evaluate that to find the y value. So all that means is that instead of x, everywhere there was an x, I'm going to put a 2. 3 times x, okay, plus 1. So everywhere there was an x, I replace that with a 2, and then I do 3 times 2 is 6 plus 1 is 7. All right, so I can then summarize this to say that f of 2 is equal to 7. I can write this as an ordered pair. When I input 2, I output 7. Okay? That's evaluate. So we also can solve a function, and solving is just sort of the opposite. So when we're going to solve a function, we're given the output and we want to solve for the input. So in other words, we're given the y value and we want to solve for the x value. All right, so let's take the same function as before. We've got y equals f of x, or y equals 3 times x plus 1. And so in function notation, I've told you here that f of x equals 0. So that means we're told that the y value is 0, and we want to solve for the x value. We don't know the x value, but we know that the y value needs to be equal to 0. So what do I do if I want to solve for that x value? Well, I told you the y value is 0, so I'm going to replace y with 0, and then I'm going to solve for x. Okay, so to solve for x, I need to isolate x. Meaning I need to get it by myself. My goal is to write this as x equals something. So I have to do some operations here. So first I've got 3 times x plus 1. So my first task is I want to get rid of that plus 1. I do the inverse operation. So I have a plus 1. The opposite or the inverse is minus 1. So I need to do that to both sides. So I get negative 1 equals 3x. Okay, that's an improvement, but I'm still not done. I have 3 times x, and here's my goal. I want to end up with x equals. So to undo that 3 times x, I need to do the inverse operation, which is the opposite. So the opposite of multiplication is division. So I'm going to divide both sides by 3. That reduces out. I get x equals negative 1/3. So I just solved for x. So let me finish it off and write this now to say that f of negative 1/3 is equal to 0. Okay, so when I input negative 1/3, I get an output of 0. So notice that there are a number of ways that I can write this. I'm using function notation here. I'm writing it as an ordered pair here. Lots of different ways. You should get comfortable with shifting between the different ways that we can write this in words and also in mathematical notation. All right, so we can also use tables to evaluate and solve functions. So when I look here, I'm saying evaluate f of 4. So this means find the y value or the output when my input is 4. All right, so remember I said earlier that when we write relationships or functions in tables, we've got the input on the top row and the output is on the bottom row. And we can see this here as well because this says these are x values. These are x values or inputs inside the parentheses, and then f of x is on the second row. Okay, so this means that we're given x equals 4 and we want to know what f of x is. So I'm going to look to where x equals 4, travel over here. When x equals 4, f of x equals 27. So we can just simply write that f of 4 is equal to 27. We could write that as an ordered pair as 4, 27. So the next one says solve f of x equals 7. So it really means solve for x when y is equal to 7, or when the output equals 7. So here, this is my output. So I want to go to my output row and I'm going to go across until I find where I have an output of 7. So when the output equals 7, the input equals 5. So I can then write this as f of 5 is equal to 7. And again, I could write this as an ordered pair as well. When I input 5, I output 7. So all of those are just writing the same thing in a slightly different format. Okay, and lastly, we can evaluate and solve functions from using graphs. And so in this case, I've not told you which one. I want you to get in the habit of being able to recognize whether I'm evaluating or solving. So in this case, I'm given the output. I'm given the output here. Okay? And I want to solve for the input. I don't know x. So think about it in terms of x and y, and which one are you given and which one are you looking for. When I'm looking for the x value, I'm solving. When I'm trying to find the value of y, I'm evaluating. So here, and always remember, we can write this as f of x equals y if that helps initially. So we know that y equals -1, and we want to find what does x equal when y equals -1. Well, let's find. Here's my y-axis. Here's my x-axis. So if y equals -1, I want to travel down until I get to here's -1. And then I want to travel over until I hit the graph right here. What x value is that? 2. So when y is -1, when x is, sorry about that. Yeah, when y is -1, x is 2. So I can say 2, -1, because when I write my ordered pairs, I always write the x value first. Okay, so this I can say that f of 2 is equal to -1. So what I did there was I solved for x. Here, on my next example, I'm given the input, or I'm given the x value, and I want to evaluate. I want to evaluate so that I can find the y value. So what I'm going to do is I'm going to read my graph. I want to look where x equals 0. Well, x equals 0 here, and I'm going to travel up until I hit the graph, which is 3 here. So I know that when x equals 0, when I travel up, it intersects the y value of 3. So I can say that f of 0 is equal to 3, and it maps right to this ordered pair here.